You probably have heard of a series of unfortunate events, but let's be more cheery. Alberto Ríos, staff engineer, and Bella Bai, software engineer at VMware, will instead talk about a series of fortunate events. And these fortunate events involve building an operator in Java. To you guys.
Hello, welcome to a series of fortunate events. Some of you might have read the book or watched a series of the absurdist children's fiction called A Series of Unfortunate Events. Even if you haven't, what happened in the past year and a half was probably more unfortunate and absurd than the book or the series. Fortunately, we're not going to talk about unfortunate events today, only fortunate ones, because events that a Kubernetes operator listens to are predictable, repeatable, and reliable. We will walk you through building an operator in Java to turn those fortunate events into desirable outcome with slides and show you a quick demo at the end. Feel free to pull down our sample app right now and follow along throughout the talk. A little bit about ourselves. My name is Bella Bai. I'm a software engineer building an operator to provide off-the-shelf Spring Cloud Gateway experience on Kubernetes. I'm based in Boston, Massachusetts. I'll pass it to Alberto to say hi too.
Hello, everyone. My name is Alberto Ríos, and I'm Bella's colleague. We're working on the same project, on the same team, and I'm based in Seville, in Spain.
Okay, our team has a long history of building operator-like software. Before we started on Kubernetes, we were building service brokers for Tanzu application service users to provision battery-included Spring Cloud Gateway instances on demand. About 2 years ago, we expanded our focus onto Kubernetes and found that we can deliver the similar self-service experience on Kubernetes with the operator pattern. So we've been building and improving our operator since then. There's a closing keynote about our product right after this talk, so check it out if you're interested. There were a lot of learnings along the way, and we hope to share some of that with you today. Let's start with clarifying what is an operator. Operators are software extensions to Kubernetes that make use of custom resources to manage application and their components. Operators follow Kubernetes principles, notably the control loop. In Kubernetes, control loop is what controllers essentially do. They watch the state of your cluster. The request changes where needed. Each controller tries to move the current cluster state closer to the desired state. The native case controllers make sure the native resources are running as desired, and the operators work in a similar fashion, but with custom resource. The operator pattern consists of 3 components. First, a domain-specific language that describes the desired state of the application in a declarative way. In the case of operator, the requested state is usually defined in a custom resource. And by declarative, it means the definition should not contain the implementation logic. Next, we have some resources to manage. This could be 1 or more applications, or some Kubernetes resources, or some data, or some infrastructure external to the cluster. Finally, the center of the diagram, a controller that runs continuously. It reads and is aware of the state. It runs actions when operation state changes in an automated way, and it reports the state of the application in a declarative way. So that's how operator works. But why do we need it? This is a definition given by Jimmy Zielinski that I really resonate with. An operator is a Kubernetes controller that understands 2 domains, Kubernetes and something else. By combining knowledge of both domains, it can automate tasks that usually requires a human operator that understands both domains. From this quote, we can get a more clear understanding on the use case of the operators and custom resource definitions. CRDs can be used to describe business knowledge, and a Kubernetes operator is just like a human operator that reacts on tickets or alerts and make magic happens. The business domain in our example is a serious cause. We need better managed automated adoption centers, and that's described with this kind adoption center. Then we want to register some cats to the adoption center. Here comes another kind, cat for adoption, that contains some basic information about the cat. The adoption center name field tells our operator which adoption center to register this cat to. So the topology of the system will look like something like this. When adoption center custom resources are applied, our operator will deploy an adoption center application for each one of those resources, which includes a Kubernetes deployment consuming a config map. With the cat for adoption custom resources, our operator can register cats to adoption centers by adding the cat info to their corresponding config maps. This is a perfect example of combining Kubernetes knowledge with business domain knowledge. Now, I'll hand it over to Alberto to talk more about when to use an operator and when not to.
Okay, thank you very much. So now that we know what they are, the next question to ask ourselves should be, do I need one? So let's see when it is a good idea to use an operator. So first, when we want to deploy applications on demand that should be running without any human interaction, that's a very good use case. Also, there's one of the biggest problems, which is the one of managing state. By leveraging all these Kubernetes capabilities, such as self-healing and reconciliation, we can turn our application into a highly capable offering. Operators are particularly useful as well when we want to handle upgrades of the application code alongside some related changes such as database schema, migrations, or schema configuration settings. And last but not least, they can also provide a decentralized way to manage centralized resources. For example, what the Nginx operator does is reading every single ingress configuration added to the cluster, and they add it to a managed Nginx instance deployed and managed through the operator. However, more important than when to use them is when not to. So we need to understand that operators are complex systems to develop and maintain. So we really think twice if we want to go this route, because it is a full-time job to build one, and it's going to add a lot of overhead, complexity, and time for you and your team to deliver new features. So it's all you have. It is just an app with some configuration. Then your CI/CD pipeline can easily do all that for you, right? If you don't need some special business logic for handling most of the operational work and can deploy it as it is by leveraging the capabilities Kubernetes already support, then this is definitely not for you. For example, you don't need an operator to scale the app based on traffic. You can just use a native autoscaler, right? And if you can deploy everything with Helm or Customize or Carvel and can parameterize everything that you need with using any of these tools, then forget about CRDs and operators. And last, if you don't have the need for any kind of persistent or status to be backed up, because you can just back up everything in the external database or cache or whatever you have, then don't create an operator here either. Actually, one of the products we maintain, we're just releasing as a help chat without an operator because we were able to handle everything with configuration and parameterization. And our users are very happy with that because they can just go and use it as it is. Right? It is way quicker for us to implement new features. So we all are happy. And next, Bella is going to talk about how to build one from scratch.
Thanks, Alberto. Let's go over how to get started in a high level. The Kubernetes community started with using Go for all the infrastructure and component code. But Kubernetes can be extended with any language or any framework, as long as it conforms to the Kubernetes standard, the APIs, including using Spring. As a result, you can find many frameworks out there that can help you simplify the communication with Kubernetes API and help facilitate resource watching and control loops. Since we're all Spring developers here, maybe there are some other languages, but it's a Spring One conference. Let's say we're Spring developers. Let's pick one that supports Spring. Kubernetes Java client is what we're using in the sample app and our day-to-day work. When we just started, that was the only library with solid Spring support and has the word official client in the repo description. So we went with it. It does what it's supposed to do, and the community was quite responsive whenever we need to get something fixed. So that's really nice. Java Operator SDK is also pretty nice and easy to use. I saw people posting in the Slack channel recommending that as well. The interface looks neat and it has some opinionated but reasonable default behavior that I like. I was hoping to also have the module implementing the same operator with this library, but that deadline defeated me. Maybe if you can check in the repo in a month, you will find that module, but no commitment. So after we decide on the library to use, we can then generate our custom resource definition. If you decide to work with Kubernetes Java client, there is a generator module that can generate the model classes and the API client classes based on the CRDs you have. Or if you are going with a Java operator SDK, they provide a tool to generate the CRDs based on the model classes you define in the code base, the opposite way. Whichever you choose, make sure you are maintaining single source of truth, so you don't run the risk of models in the code goes out of sync with CRDs applied in the cluster. Then you can create your controller watching the resources and filtering the type of events you want to reconcile with. Here's an example controller using Kubernetes Java client. We're watching the adoption center custom resources and ignoring all the update and delete events by returning false in the filter. We're telling the controller to use adoption center reconciler instance to handle the onAdd event. The configuration is pretty straightforward. And back to these slides. After setting up the controller using a reconciler instance, now all we need to do is to fill the reconcilers with business logic and resource management calls. Here's an example reconciler with pretty much all the logic for the adoption center. Because we only take onAdd event, we just need to create config maps and deployments when we observe a new adoption center custom resource request. Obviously, if we want it to be more resilient, we can always add more logic to handle edge cases. And that's a high-level idea of how you can start a basic operator. I'll pass it to Alberto again to talk about some nice add-ons to enhance your operator.
Thank you again. So let's say that we have now a working operator. What are the things we wish we knew when we started creating ours? To me, the lowest hanging fruit you could pick to help your user is adding a status. At first, you do keep CTL, a get, and your CRD, and you're going to get a very, very sad and lonely output. Meaning that it will be really hard to debug what's going on as a user because we won't know if the creation went well or not, or what happened. There is no information there. There is no feedback, and the only way to know as a user would be to go and check out the logs, and that might give you some idea. So this is not ideal. It is super easy to add these sections to the output to inform the user how the creation, update, or everything went, right? So this is what we're going to do next. What we're going to add this to the output. So there's a standard section of our resource called status, and to implement it, we need to do a couple of things. First, we need to add the status section to our schema with all the elements that we would like to display. As we see, this goes in the same level as the spec, and because it is a sub-resource for our object. So in this particular scenario, we are adding this object called type and a status. You have the full example in the sample repo, so don't worry, you don't really see the whole YAML over here, but hopefully you get an idea more or less of what needs to be added here and there. So once we have this status created or added to the schema definition, we need to add another thing. And this is something that goes into the version, and it is called the additional printed columns. They go into our CRD, meaning that these are going to be the extra columns are going to be printed as an output. As you can see, we can reference conditions or anything using JSON path. And again, they go at the same level as the schema section of the YAML definition. And again, the YAML is available for you, so don't worry, you don't get the formatting right. So now that we have the sub-resource and the columns, if we go and regenerate our model using the method that I mentioned before, our Kubernetes client will have a new method available for us to patch this status. This is how we do it in the code, right? So the easier way is by patching that sub-resource using a merge patch. The input is typically that patch to the new sub-resource we created with the values that we want to specify. In this case, the relevant ones are the type of the operation, the status, and maybe the reason. We have a class with the method that we call in different parts of our reconciliation loop, typically on success of every other operation, and also when we're handling errors. And after all that, we should be able to see the full output with what we specified. We can have as many columns as we need, and it will depend on your own use case, what you want to add there. But to me, at least, it is the ready and the reason, right? Just to know it is working or not and why it is or not working. So these are the two that I would definitely add. And then another interesting pattern that we should keep in mind that I kind of wish I knew. So because sooner than later, there's going to be a story in your backlog, right? With something like when I run kubectl delete my adoption center, then I want to see all the dependent resources gone. Like, for example, every time we create an adoption center, we create a deployment, I made a config map, and in the future, who knows what we are going to create, right? So we're going to create a lot of resources after that. Because when we create all this, it's a manual step, right? We don't want to go and manually be deleting all the sub resources that we create with this. So it is very typical when you start creating your first operator to include some lines like this. We go and if it's a deletion the request, we want to manually delete all the sub resources. Well, not manually, but programmatically all the sub resources. But there is a better way to do this that doesn't require us to programmatically do anything on deletion. And there is this built-in mechanism called owners and dependents that will do all that automatically for us. So some Kubernetes objects are owners of other objects. For example, a deployment is the owner of some pods, right? That's the most typical basic example. And every dependent object has a metadata owner references field, as we can see on this example here, that you can set that points to the owning object. So we take a better look to this output. We can see how the deployment that was created by the adoption center reconciler is an owner reference to that instance of the adoption center. And in order to implement this, it's nothing more that every time that we create that new deployment that's dependent in our custom REST definition, we add the owner reference to it. So again, we have this function that we keep calling on create of every sub-dependent resource. And now after this, we can go and delete all that ugly lines of code because it's going to be done automatically for us. And next, I'm going to pass it to Bella, talk about readiness gates.
Yeah, readiness gate. Readiness gate is a feature based on status. A pod is only considered ready when all containers in the pods are ready and all conditions specified in readiness gates are true. This is a method to ensure additional conditions happen before Kubernetes can consider this pod ready. For example, we want to wait until a backup instance is up or wait for data synchronization to finish. These conditions are usually external to the pod. Does anyone know why? Anyone wants to post in the Slack channel? If you're not in the Slack channel, maybe pop into the Slack channel. Maybe it's taking some time for people to show up there. So I'll just reveal my take on it. My take on it is that if the conditions are internal to the pod, it would be much easier to use readiness probe for it. Components in Kubernetes are supposed to be autonomous units that are aware of their own health, just like us humans, and sadly, even better than some of us. So readiness probe is more appropriate if it's internal condition. The condition type in readiness gates is just an arbitrary string of your choice, following the format of a label key. Once you set that in the pod spec, you may use your operator to monitor for the custom external conditions and make a status patch call when the conditions are met. I didn't add any readiness gate to the sample app because I couldn't think of a reasonable use case for it in our simple use case. Any suggestions and PRs are welcome and appreciated to make the sample app better. And next, let's talk about finalizers. Finalizers are namespace keys that tell Kubernetes to wait until specific conditions are met before it fully deletes resources marked for deletion. You can use finalizers to control garbage collection of resources. In short, it enables controllers to implement asynchronous pre-delete hooks. You might be wondering, why garbage collection again? We just talked about owner reference, didn't we? For sub-resources that a custom resource have full ownership with, sure, owner reference is the best way to clean up that sub-resources. But if each custom resource only have impact on a portion of a sub-resource, then it will require something that understands the domain to clean up that portion. And that is our operator. In our sample use case, our cat for adoption custom resource contributes to only one entry in the state of the adoption center. Let's see what would happen if we delete the resource without finalizers. Imagine you have 3 cats registered with this adoption center, and the 3 puzzle pieces on the left are custom resources representing them in Kate's API server. when a cat resource is removed, say this top puzzle icon is removed because the cat has been adopted, we need to make sure in actual state on the right, the grayed out cat information is no longer showing in that adoption center's endpoint. However, without a finalizer, the desired state of that resource is null. All we get from the delete event was a cat resource name and a namespace. We don't have a way to know which adoption center the cat resource was associated to. The operator will have to search all the adoption centers and remove this cat. It's not impossible to do, but certainly not efficient. Moreover, what if the operator is temporarily offline when that happens? The deletion would be done, and the operator was not watching, so won't even receive a delete event. The newly started operator wouldn't even know that the cat was ever existed. That's sad, isn't it? But with the finalizers added to the resource, Kubernetes will add a delete timestamp on the resource metadata to signal the intent of removal and allow us to perform any pre-delete operations until the finalizers are removed. In this case, even if our operator is currently offline, we can be rest assured because we know that the cat will be eventually removed when operator comes back online. This is how this pattern is used in the code. Our controller will add a finalizer to the cat resource on create before performing any operation and remove the finalizers from the resource after finishing all the pre-delete operations. And if you are using the Java operator SDK, the framework automatically adds and removes finalizers for you. So you can save this effort and don't need this part of the code. And here's the code that cat finalizer editor uses to add finalizer. It's just a simple patch call similar to what we did with status before, but it's patching on the metadata, adding the finalizers field. So finalizers are great to have, right? But wait, there's a catch. The finalizers really require the operator to be up for resource deletions. So if your operator adds finalizers to some resources and you uninstall the operator, then you may find those resources hanging in deletion forever unless you manually remove the finalizers. What should we do? Well, this is not actually a bad thing. We just really need to think about what you want to do with the resources left behind and how you want your users to experience. Do you want to force delete everything when operator shuts down or restart because you know that they're all saved to delete? Or do you want to force delete when you only uninstall the package? Or you want to cancel the uninstall command and tell users to delete those resources first because you want them to take the responsibility? Or you want to design your uninstall process so that the operator is the last one to tear it down. Or maybe you just want to simplify document it and tell your user how to get out of that pending deletion state. I don't have an answer for you. This is an opportunity to think about your own use case and your own users. And that's all for finalizers. Alberto, back to you.
Okay, thank you again. So let's talk about validations now. Validation is a crucial aspect of every system, and without it, it can lead to services, application, or even the operator to misfunction. It is not possible to validate a custom resource in a controller. And this is the flow Kubernetes follows every time we execute a command like kubectl apply -f my cat. It will go and decode the request, convert it into internal type, validate it, and then convert it again so it can be persistent in etcd. And after that, it will go and return the response, as we know. And the problem about this is once the request or the persisted object is in etcd, the controller that owns it cannot do anything to reject it. And the custom resource is not valid. Trying to use it in the controller will result in an error, right? So how can we contribute to that validation? There are two types of validation that we can perform. They're called syntactic validation and semantic validation. The first one we're going to talk about is the syntactic validation. And it happens by defining open API validation rules when we define our schema. You can specify things like format, what's required or not. On this particular example, we made the name and adoption center mandatory fields. And we say that the date of birth is going to be using this specific date format. But apart from that, you can also add things like this, meaning that we can have something more complex. There are other rules that you can add, like we may have the property A set or a property C nested inside a property B. As you can imagine, even if this syntactic approach is very powerful and there's a lot we can do with it. As a note, our first version of our operator just uses syntactic validation. That's what we do to validate today, and it's going well enough for us. However, this is often not enough. And we need something more complex. We need to go now to semantic validation. So we zoom in to what actually happens on this validation box. We see how there are a few webhooks we can contribute to. Right? We have mutating webhooks, and they are used to transform some requests, typically used by version upgrades, for example. Then we have the validation box that we talked about before, where we validate the Open API schema. And finally, we have validating webhooks. Over there, inside of validating webhook is when we can add our logic, and by creating something called a validating admission configuration. So apart from the weird name, this is more or less how the function will look like. This is what your validation will look like, more or less. We get a validation request, and we get our object from the spec, and say, assert on the conditions we want to allow that request to happen or not, and then we send it back. The problem with this is not that trivial to implement. I mean, it is trivial to implement, but not to maintain. To create one of these, you need to deploy a new component that must be always up and running and always be active. You need to add a good bunch of configuration to it, and you need to maintain all the certificates to the new component and the Kubernetes API, because that's got a communication that's going to be happening constantly in between. So this is not as trivial as the previous one. And now, with that out of the way, we are going to talk about one of our favorite topics, and that is testing. Since creating an operator is something that requires a platform, it's going to be managing services for many users. Testing efficiently is more important than ever. So every arrow here that we see is going to be a call to the platform or to the resources we manage. So testing is going to be a crucial aspect for us, because it is very easy for us to have long test cycles when developing this kind of systems, right? This is something that we as a team, we decided to put a lot of thought into how to test this well, so we have shorter cycles. You can find all the tests in the sample app. At least we try to have one example of each. We may even open source our operator in the future, so you will likely be able to see the whole thing end to end, but hopefully you can get an idea on how testing should be done. So we have the following with testing layer, unit. You probably can imagine what this looks like, nothing fancy, just the main place where we test everything. The majority of our coverage still comes from there, and we test drive everything in our reconciler and operator. Then we have component test. A component test is a closed box test, but from the operator's perspective, meaning that we do not assert on the actual correctness of the application deployed, but on the values what's deployed with. So we focus solely on one component at a time. In this case, we just focus on the operator. And how does one of these look like, you may ask? So if you have opened the sample app, you will find that we reference a tool called Kind. Kind stands for Kubernetes in Docker, and it is really amazing tool that we use a lot when working with Kubernetes. It has a lot of features compared to Minikube and other development tools, but the main thing is that creates a brand new cluster in under 30 seconds. So we create a Kind cluster when running our component test. So we have this annotation configuration that you can see down there that they enable us to auto-wire Kubernetes client pointing to the cluster that you see. You will see in the sample app. And then our test is executed, and our operator runs in the test thread pointing to that cluster. So we can debug and test everything very quickly. One thing to note, because the CRDs are per cluster, you will run into issues when doing parallelization in one cluster. So in our real project, we wish we had something like test container for Kind, but that's not very stable yet. So what we do right now is we manually create a Kind cluster per test execution. And that's how we enable parallelization. We haven't migrated that to the sample app yet. We might, if you ask us to, but we are going to go to, we are hoping to open source the full project, so maybe you will see everything over there. And this is a very condensed version of one of these tests with the annotation enabled. We can see that how we auto-wire the Kubernetes test client, whatever we want to assert on this cluster. So what we do typically here, we prepare the CRDs and then just create some cats and assert on the values. We have a couple of examples like this in the sample app, so do not worry, you do not follow along. Some maybe wonder, why this and not just a good bunch of acceptance tests in a real cluster, testing everything end to end from the user perspective? Well, ATs are great, but they're very slow and they require a real cluster, meaning that you have to choose between waiting for minutes or waiting for a few seconds to receive some feedback, right? That's a call you need to make. And for a lot of features, this should be more than enough. But leaving, component tests are great for most of the features, right? You don't need to do everything in acceptance because then you're going to have super long test suites, right? We should leave acceptance tests for the user experience. So how do we do that? How do we do acceptance tests? We use a real environment, and in our case, Tanzu Kubernetes Grid integrated. We prepare our environment the same way our user would do. In our case, a script that does a Helm install. So that's how we run everything on our CI environment. And then we run our test suite. We have to run tests that assert on a specific feature itself, like given that I create a cat with these properties, when I go to the adoption center, then I see that cat over there. And these tests are good, but it is very easy to abuse and add an acceptance test suite per new feature without worrying about what was there before, right? So right now in our project and in the sample app, you can see one of these, we are doing something called journey test, where we test a full set of features with a particular user in mind. So for example, we know there's a user who cares a lot about features A and B, configured on this way with feature T over there too. So we test all that together. Over here, we're just creating an adoption center. We're adding a cat to it, and then assert that adoption center has the cat, and then we test deletions and that all the sources were deleted. This is a simple example, but this kind of identifies how all these journey tests work, because otherwise we could have an acceptance test for creation of one component, creation for another component, another for deletion, right? So this is a nicer way to test a few things all together that when they make sense. And now Bella is going to show us how everything works together. Demo time. You're muted.
I'm muted. Okay, I'm back. Okay, I forgot to start scaffold dev before this talk, so we'll get that started. And in the meanwhile, we can take a look at the code. I'm pretty sure some of you have already put down the code, but I'll just give you a very high level overview of how this repo is structured. We have Adoption Center, which is that app that will be deployed by our operator whenever Adoption Center custom resource is created. It's a very, very, very simple Spring Boot app with an endpoint called animals. It returns all the animals it receives from properties. And the properties will be read in from our config maps. And the config maps is also created by our operator and get updated every time when the new cat is added. So that's our adoption center, very simple. We have our, with Kubernetes Java client module that has a configuration file that has a lot of the configuration beans that I mentioned before in the slides. You can check that later. And then we have these two reconciler, one for the cat adoption, cat for adoption custom resource, and the other one for the adoption center. The idea is maybe at someday we'll have some dogs, rabbits, or birds, and each of them will require a dedicated reconciler handling the specific logic for that specific animal. So it's very extensive. I have to say, I love all animals, even though I love cats the most. And we have some other individual modules. We have them separated out. So each one of those class is handling one thing. Like this one is handling only the finalizer for the cat. This one is changing the status on the cat. This one is about updating the config map, like operating around the config map. This one is operating around the deployment. Having them separately is going to help writing component tests a lot easier, because you're just testing one piece of functionality. And when you test the color of them, you can safely mock them out because you've tested them with a real cluster. And you're confident that your assumption about the cluster or your assumption about the API client is correct. So when you test the color of it, you can safely mock it out. Yeah, so the tests are pretty much similar. We don't have a really good example of our unit test because sample app and timeline, and like put them together, you get the answer. What else? Oh, CRDs. Here we have our 2 CRDs we created, one for cats, one for the adoption center. And these generate models for CRD is used to generate the model classes here. We have an API client that can do all the things around our custom resources, and then the generated classes are all there. I think in the README, there is a documentation going directly to the code base, their original documentation. So you can check that out as well if you want to learn more about this. And the last one is Scaffold. Some of you might know, some of you might not know. So I'll just quickly introduce to Scaffold as well. So Scaffold is a really good way to put to help with local development. In this build section, we're telling it to build these 2 images, and it will be tagged with a special image SHA. And then in the deploy section, we have these 2 manifests, the CRDs will be applied. And we're also deploying everything under this manifest folder, which is a bunch of operator resources like the deployment, cluster role, namespace, and everything. These 2 are not included because they're just test resources that I'm using, that I'm going to use right now for demonstrating this app. It's ready. You can see our adoption operator is up and running, and there is no cats. Yeah, it's not showing the command, but on this corner here, it's showing listing all the cats in all the namespace. So let's create a cat. I mean, not creating a cat. I'll just put in the default namespace. It can be in any namespace. So you can see here, it's right away, it's saying it's not ready because config map is not found, because the adoption center with this cat should be associated to is not created yet. So now let's create that adoption center. Okay, adoption center is a cluster-wide custom resource in this sample app. So it can be applied to any namespace, and you'll see the deployment of this kitten streamland, a part of kitten streamland, and there will be a config map, but sorry, I'm not watching on it right now. Take my word, it's there. Because look at the cat section here, cat is added to config map. However, we're still waiting for the pod to be up. So that's another improvement we can potentially do, because right now we're only setting the cat resource to be ready whenever we add it to the config map. But what we can potentially do is having a separate reconciler watching on the deployment resource that the cat should be published on. And when we only set this status ready when this deployment is ready, that will be a great feature to have. So if anyone is interested, feel free to contribute to the code base. It should be a relatively simple exercise. And the deployment is ready. So let's port forward that to 8080. I'll just kill this one and curl animals. We see our cat, Chocobo. That's my cat. That's my first cat. My second cat is sleeping over there. And Chocobo is lazy, so she won't be here. Anyway, so that is a demonstration of it. How long do we have? Maybe we can do update and delete a little bit more too. What do you think, Alberto? Do you think we have time?
Yes, so just delete maybe.
Yeah, we can delete. Safe. So let me start the watch again. I guess we don't need to watch. I'll just delete cats, all of them. There's only one actually. Yeah, this is the only one. Whoops, something bad is happening. See, sample app needs help. But let's curl it, see if at least it works. No, delete doesn't work. Delete the cat doesn't work. Oh, maybe we didn't test it. We didn't test deleting cats in our journey test. That is why we're missing tests. Well, I guess we can delete our adoption center. Kitten Streamland, and you can see all the sub-resources for Kitten Streamland are terminating and removed. And now we really don't have that cat anywhere. Cool, and that's the demo. Not super successful, but hope you get a point.
I still think that's pretty good. It's really amazing. Well, the whole thing, how everything is working together. Well, this is
Hope
coming.
everything so.
Yeah, it is good. Well, this is coming to an end, so let's just go and summarize a bit everything, right? Let's see if my slides, I cannot see my own slides. Okay. Yeah, so let's summarize a bit everything what we have learned. So we have some takeaways, right? So operators are an excellent way to manage continuous reconciliation of resources, and it is a standard pattern to manage application infrastructure. There are a few use cases, and they can be really useful and the way to go. However, there are complex systems to maintain. So try not to create one if you can avoid it. However, there are a lot of projects that can help you with starting with this. We have used the Kubernetes Java client on Spring, and it worked really well for us. It's working still very well for us. There are newer projects out there that might be interesting for you. And to be honest, scaffolding is not that important. It's something that you do the first day and then kind of forget about it afterwards. So try not to overinvest in trying to use every fancy new tool available. Just use the minimum that get your work done. Then we recommend having some advice, mainly having one source of truth. We are using generating the Java class from the CRD, but whatever works for you. But this just have one source of truth. Otherwise, you can have all this weird status or model mismatching everywhere. And then remember, you can add statuses, finalizer, readiness gates, and owner references when you're creating your objects. And last but not least, do not list testing as an after thing. By looking at the sample app, you should be able to test drive everything and have a great confidence level with very short feedback loops. Now it is your turn to try this out. So we check out the sample app. Let us know you have any questions, you want to contribute, you're interested in any particular pattern. We can help you out over there through PRs. And if you have any questions, we're going to be hanging out in the QA room and see you around. Thank you so much.
Thank you for joining us.
Thanks, Alberto and Bella. So now, everyone, you can head to the Q&A if you go to the Slack channel for this talk. And then after that is the keynotes or the main stage for the end of the day.